Okay, class, look at the screen. We have a right angle triangle as shown over here. What page is this on? Page 3. We see some words in bold. This word, opposite, I'm sure all of you know what the word itself means. Then we've got the word adjacent. Have you heard of this word before? Adjacent? When? Angles. Adjacent angles on a straight line, right? Okay, what about this word over here? Hypotenuse. Have we learned it already? Yes, it is the longer side of the right angle triangle. So, for any right angle triangle, the hypotenuse, you will be able to tell which one it is because it is the longer side. Students generally have a problem finding what is the adjacent, which is the opposite side of the triangle. So how do we decide which side is opposite, which side is adjacent? Now these two words, these two English words, when they are used in a sentence, they are used like this. AC over here is opposite to angle something. I'll fill in the blanks with you later. And the side BC over here is adjacent to an angle. Okay, so now we are going to figure out which angle are we referring to. Because in a right angle triangle, we have 3 angles, one of which is the 90 degrees already. So nothing to talk about that. I've got 2 remaining angles. If I have this angle over here, I call it angle ABC. This is angle ABC. The side, these are sides of the triangle. The side opposite to angle ABC will be AC. Okay, can you see that this side AC is literally opposite the angle? It's on the other side. So we call this side opposite. Must get this right. So the other one, for the same angle, angle ABC, I've got an adjacent side. Adjacent means right beside, seated side by side. If you look at the person on your left, on your right, they are adjacent to you. Okay? So this side, this length, BC, is beside the angle ABC. So we call this. So you write it like this. BC is adjacent to ABC. Alright? Now, I want you to use another color. Use another color pen. Mark out this angle. Okay? For the blue angle, which side is opposite to that blue angle? Which side is opposite to the blue angle? BC, excellent. So for the blue color, this is my opposite. Now can you see why students may be confused? The same side, BC, sometimes it is known as adjacent, sometimes it is known as opposite. It depends on which angle you are using as a reference. So for the blue angle, the opposite side is BC. For the blue angle, which is the adjacent side? Is it AC or AB? AC. So this is the adjacent side. Then what shall we call the side AB for the blue angle? It is still the hypotenuse. Because it is the longer side. Yeah, exactly. So now, fill in the blanks for these 2 triangles. You have the first one, longer side, hypotenuse. Okay, cause I don't know how to spell. But you must know how to spell. So same over here, hypotenuse. Okay, now which is the adjacent side for the first triangle? Adjacent, which one? BC, okay, adjacent. What about AC then? Opposite. Then this must be our opposite. adjacent. Okay, now. Okay, so this is what the diagram is about. I've got 3 right angle triangles. All of these right angle triangles have one angle at 60 degrees. Okay? Do you remember what similar figures are? What are similar figures? All got same angle, right? So are these 3 triangles similar? Are they similar? Are all the angles the same? Do they all have a 90 degrees? Do they all have a 60 degrees? And what is the last remaining angle? 30 degrees. 30 lah. 30 degrees for all of them. Now, all these triangles, are they of the same size? No. The one on the left is the biggest, the one in the middle is the smallest. And we've got the lengths as shown when it is drawn accurately. Okay? These values that you see as the length, they are not random numbers. They are the exact values for these 3 triangles. Your job now is to write down the ratio. So this word ratio, you can treat it as a fraction. Write down the fraction of the opposite side divided by the adjacent side. So for the first one, this is what we will write. Opposite will be 8.65 divided by 5. Then use your calculator, figure out what is the value. We get 1.73. Okay? Second triangle, third triangle, write them down yourself. And all of you turn on your calculator. You should see a little capital letter at the top, regardless of calculator model, D. You see a letter D at the top? You see RAD, then yours got problem already. Okay? It must say D for donkey. Cannot be R, cannot be anything else. Okay? Go and figure out how to change from any other letters to the letter D for degree. Because we are using degrees over here. Now search for the letter TAN in your calculator. Okay, over here. TAN for tangent. So over here, there's the letter D at the top. So press tangent. Then you see an open bracket. What is the angle that we are supposed to use? 60. You can close the bracket if you want to. For me, I'm too lazy. I'll press equal. What is the value? 1.73. 2. So to 3SF, I have 1.73, which is exactly what was shown in the earlier questions. Okay? Now, for some of you, if your calculator is in a wrong mode, for example like this, I press shift, I press mode, and then you see, number 3 is degree, number 4 is radian, number 5 is gradient. Some of you may have a letter R over here. It is in a wrong mode. So if I key in tangent 60, I will get a different value. So is it important that your calculator is in a correct mode? Yes. Figure out how to change it back. If you need help, come and look for me. If you are using this model, press shift, mode 3, and you get back the letter D over here for degree. That is if you are using this Casio model. For 60 degrees, and this is what you need to know, tangent 60 degrees is a ratio. It is the ratio of the opposite side over the adjacent side. Opposite here over the adjacent. And you will always give me 1.73 as shown in your calculator. Doesn't matter the size of the triangle. So, our triangles are not always 90, 60, 30. I can have other angles such as 90 degrees over here and maybe 50 degrees. So tell me now, what is the ratio of the opposite over adjacent? Let's put this on x and y. What is x over y equal to? X over y. Opposite divided by adjacent. That is tangent 50. Hit your calculator now. Tangent 50, what do you get? Tangent 50, 1.191. So this is 1.191 rounded off to 1.91. This is a ratio. There are no units. It is a length divided by another length. Huh? Oh, sorry. 1.19. Okay, this is a ratio 1.19. So you have to be familiar with how to use your calculator to find these values. Now, for the same triangle, we're going to find out other ratios because it is not, we are not restricted to just opposite over adjacent. These are the same three triangles. Write down the ratio of adjacent over hypotenuse. So it's 5 over 10, which is half. 2 over 4, 4 over 8. And quite clearly, you see that the ratio of adjacent over hypotenuse is half. It doesn't matter what size the triangle is, as long as it is 60 degrees over here. So now tell me, if this is 6 cm, the adjacent is 6 cm, how much is the hypotenuse for this triangle? 60 degrees, 90 degrees over here, 6 cm as the adjacent. How much is the hypotenuse? Given that adjacent over hypotenuse always will give you half. So 6 divided by something must always give me half. What is this something here? 12. This is 12. If you are asked to draw a triangle, 60 degrees, 90 degrees, 6 cm and 10.38 cm, you'll find that you have no choice, but this is going to be 12. You can draw it out yourself. So now, this ratio, adjacent over hypotenuse, is called cosine. So we're going to find it on our calculator. Okay, clear everything? Which button should I press? COS over here. Okay, so cosine, and the angle, how much is it? 60. Let me get half. Don't know how to change, never mind. We'll figure it out later. Alright? Cosine 60 is always half. So, if my triangle over here has the adjacent side, let's say it is 100 meters. How much is AC? Class, watch the board. AB 100 meters. How much is AC? 200 what? Units? Meters. Yeah, that's it. Because it is 60 degrees, it is fixed. It has to be 100 and 200. It's always half for the angle 60 degrees. So next part, use the calculator, find the value. Okay, this is half. This is always half. Now, for the angle theta, because it doesn't always have to be 60 degrees again, it could be 50, it could be 40, it could be 80, it could be 89. But it can't be 90. This ratio is called cosine ratio. We call it cosine theta, where theta is just an angle. Theta can be any angle you like from 0 to 9, between 0 and 90. And we call it the adjacent over the hypotenuse. Okay? In the first ratio that we learned, we've got tangent theta is opposite over adjacent. In this page, we have cosine theta is adjacent over hypotenuse. Are they the same thing? Are they the same? Do they give the same ratio? They don't. What this means is that you need to memorize. When I tell you tangent theta, you must tell me opposite over adjacent. Can we try that? Tangent theta equals to one last one. It is known as sine. Okay, so same thing. Opposite 8.65 divided by 10. 3.46 over 4. 6.92 over 8. .865. Okay, we realize that hey, we get the same ratio, same value again for these three different triangles. And this is known as the sine ratio. So same thing, calculator, go press sine 60, and we get 0.866. Okay, then we round it off because this value is not exact to 3SF. So according to our calculator, we get 0.866. Is it the same as what we calculated earlier on? No, right? Missed by a little bit. Why is it different? Why is there a small difference? Because these values over here, okay, the 8 and 4 are okay. These values that I've circled, these are not actually the exact length. There are more decimal places behind. If we use the exact value, we will get what is shown in the calculator. Okay? So this last ratio is known as the sine ratio. So you can key in your calculator sine 60, you get 0.866. And now, last one, sine theta is opposite over hypotenuse. Who is able to memorize everything already? How you memorize so fast? Okay, so that is some not. Because the O looks like 0. Are you telling me that tangent theta is always 0? Cannot be. So we write opposite over adjacent. Where is the TOA? It is over here. TOA. The TOA. Okay, TOA over here. The next one, we have cosine theta, COS. We shorten it to COS. This will be adjacent over hypotenuse. Now you know why I don't know how to spell? Because every time I have to write it out, I write HYP, which is fine. So the letters over here, CAH over here. And the final one, sine theta equals to opposite over hypotenuse. SOH over here. So can I memorize already? I can find the ratio. I am supposed to be able to work backwards to get an angle also. In other words, if I have a triangle that looks like this, where theta is over there, the angle XZY. I've got the hypotenuse as 17, adjacent as 8, and the opposite side as 15. And then I'm able to write down all these ratios. 3 of them. Do you think this value of theta is now fixed? Based on these 3 lengths given to you, is theta now fixed? Can you have different answers, or is theta fixed only one answer? It is fixed, right? If it is fixed, you know how to find it. Okay? We'll now figure out how are we going to find theta. Using sine theta is 15 over 17. Okay, we are going to use this. You can choose to use cosine tangent, up to you. But for now, I want to use sine theta is 15 over 17. So this is what I will do. We will come back to this in a while again. I will press shift sine. Because you see, I've got a sine. It looks like power -1, but it is not. It's called inverse. This is inverse of sine. You see what appears to be power -1? It looks like power -1, but it is not. It is called inverse. It means go backwards. So the inverse of sine 15 divided by 17, because that's the question. So here I will get 61.92 degrees, meaning this angle over here, this theta value is equal to 61.927 degrees. Okay? If I choose not to use sine, if I choose to use cosine, okay, same thing, shift cosine. So now I get cosine inverse. And what is the fraction? 8 divided by 17. I get the same angle. Of course I must get the same angle, because it is literally the same angle. And the last one, tangent inverse. We have 15 divided by 8, and we get 61.927 again. Same value. Alright? This is how we work backwards to get an angle. So now we will try writing, practicing in fraction. Okay, this is what we have to do for part B. Sine theta equals to, Yao Jun, sine theta equals to? Sine. Which one over which one? Opposite over hypotenuse. Which one is the opposite to theta? Good. And hypotenuse? Good. What about cosine theta? Which one over which one? Good. 5 over 13. And the last one, tangent theta is how much? 12 over 5. So in order to do all this correctly, you must be able to identify where are our adjacent, opposite, and hypotenuse. Okay, practice 4. We write it, instead of tangent theta, we've got tangent PSR. I just write down the angle. Okay, Trigo ratio for tangent. Trigo ratio for tangent, what do we have? Which one over which one? Why are you still doing? Why are taking so long? Trigo ratio for tangent, come on, lesson ending already. Which side over which side? Tangent, tangent. Opposite over adjacent. Where is PSR? It is over here. What is the opposite side? 24 over 10. Simplified to become 12 over 5. Now for part B, sine SPR. SPR. Okay, now this is our angle. Sine. So we are using SOH. SOH. Opposite over hypotenuse. Which is the opposite side? 10. Hypotenuse 26. So we get 5 over 13. These are the two answers. Your homework is to do practice 5. Just key in calculator. I'll show you the first one. Sine 66. Press sine 66. Copy down the answer. Done. Practice 5 easy? Super easy. So that can't be the only homework. Practice 6. I show you how to do the first one. Cosine theta is 0.1353. So part A. Where theta equals to, follow carefully, inverse cosine 0.1353. Answer 82.22 degrees. Round off to 1 dp, 82.2 degrees. Easy? Yeah, so these are your homework questions. Practice 5 and practice 6. As well as question 6. Okay? 3 questions. Do we have lesson tomorrow? Do tomorrow.